Do you feel the vibes?
Hey guys, today we are going to cover 7.3 and 7.4. They are actually not very long, so they can easily be combined. Okay, in 7.3, we're going to talk about logarithms. So far in this chapter, we've been talking about exponents and exponential equations. Okay, so let's talk about powers. Okay, first I want to take a minute to talk about the difference between an exponent and a power. Okay, so if you have 2 to the power of 4, the 4 is the exponent. We all know this, right? This whole thing is a power, right? This is equivalent to 16, right? So 2 to the power of 4, the whole thing is a power. So if you take 2, right, what are the powers of 2? Well, if you raise it to an exponent of 1, it's 2, then 4, then 8, then 16. So these are the powers of 2, right? 2, 4, 8, 16. Equivalently, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. Those are the powers of 2. So together it's a power, and then just, the 3, the 2, those are the exponents. Okay, so look at what happened when we did this. We increased the exponents by 1, 1, 2, 3, 4. But look at what happened in going from an exponent of 2 to an exponent of 3. The power jumped from 4 to 8. We skipped over all of the other numbers, 5, 6, 7, and so on. What if I wanted to get a 6, right? What if I wanted 2 to the power of some number to be equal to 6? How would I find that exponent? So I definitely know it's something between 2 and 3, right? But how do I find it exactly? Well, guess what? That is a question that is answered by a logarithm, right? So a logarithm answers that question for us. Okay, so what is a logarithm then? Well, let's talk about that. If I have, right, a question like this, 2 to the power of what is equal to 6? Another way I can write it is the following: log base 2 of 6. So if I was walking down the street and I saw a billboard, and on the billboard all it said was log base 2 of 6, I would say, oh my God, somebody is looking for the exponent of 2 to get a 6, right? Okay, so why don't we take a look at that more closely? Let's look at the definition of the logarithm. So the logarithm has this format: log base b of x is equal to y. This b is, the base in an exponent, right? In a power. So let's look at it this way. Suppose we have 2 to the power of 3 is equal to 8. Another way to write this exact same thing is log base 2 of 8 is equal to 3. So look, base, power, oops, let me get a different color, power, exponent, exponent. So in other words, the answer to a logarithm is always an exponent. Okay? All right. So take a look here. Write each equation in exponential form. This is already solved, right? But we have to write it in exponential form. So take a look. Where is the base? That's the base. Every base needs an exponent. What's the exponent? That's the answer to the logarithm. Equal to the power. That's that number right there. Okay, let's do another. And notice that's going to be in, a true statement. Okay, so take a look at this one. What's the base? 10. Every base needs an exponent. -2 is equal to the power 1 over 100. Okay, take a look at this one. Where is the exponent? 6. Every exponent needs a base. What's the base? 3. 3 to the power of 6 is equal to the power 729. Now, let's write these in logarithmic form. Okay, so remember, this is the base. This is the exponent. Okay, what is the answer to a logarithm? An exponent. So the way I'm going to write this is this. Log base 5 of 125 is equal to the exponent. Okay? This one. Log base, what's the base? 27 of 3 is equal to the exponent. The exponent is always the answer to the logarithm. Here's the exponent. That's going to be the answer to the logarithm. So log base 6, 1 over 216 is equal to -3. Okay, so for these, we were just rewriting them. Next, I have to evaluate these expressions. Evaluate means actually come up with a numerical answer. So let's do this one. Log base 2 of 8. We are looking for the exponent of 2 that gives us an 8. And that's equal to 3. Again, the answer to a logarithm is always an exponent. Okay, here we go. This is a tough one. I'm looking for an exponent of 25 to get a 5. So 25 to the power of what is 5? Okay. Well, somebody might say 25 to the power of 2, because there's like a 2 in there. Well, okay, that is not equal to 5. Somebody might say 25 to the power of -2. But a negative makes it a fraction. So that's not it either. Well, what if we say 25? What should we do to 25 to get a 5? We can take a square root, right? Yeah. So that's 1 over 2 is equal to 5, right? That means the answer to this, the exponent that we're looking for, is a half. Fantastic. This one. What exponent of 4 gives us 64? 3. Okay. This one. 6 to the power of what is 1 over 36? Well, 6 squared is 36. But what makes it 1 over? -2. Right? So in general, if you have a whole number and then, a reciprocal, we know that 6 squared is 36, and then make it negative for that reciprocal. Okay, look at this one. Is this the same? Not really, because both of these, the base and the power, are a reciprocal. So that's just going to be a 2. And if you're having trouble figuring that out, just write it out for yourself. Is 1 over 9 to the power of 2 equal to 1 over 81? It is, so that's it. Okay. This one here, we're looking like for the, 10 to the power of what is this ridiculous number. What you have to do is count the zeros. 1, 2, 3, 4, 5. So 5. Right? And if it was the opposite, like 0.0000, count the decimal places, and then it'll be negative that number. Right? So log base 10.01, count, that's 2, so that's -2. Okay. All right, so the Richter scale. What is the Richter scale? You may have heard of it before. The Richter scale measures earthquake intensity. the increase in intensity between each number is 10 times. So for instance, let me erase this. If there is an earthquake of, intensity 3, or, sorry, I said that wrong. If there is an earthquake of magnitude 3 versus an earthquake of magnitude 4, to you, that's just a number, right? To us, that's just one number, 3 to 4, big deal. But really, the intensity between a magnitude 3 and a magnitude 4 is 10 times. So a magnitude 4 earthquake is 10 times more intense than a magnitude 3 earthquake. All right. So an earthquake with a magnitude of 7 is 10 times more intense than one measuring 6. The intensity of an earthquake can be modeled by y equals 10 to the power of x minus 1, where x is the Richter scale rating, the magnitude. Okay. The largest recorded earthquake in the United States was a magnitude of 9.2, and it struck Prince William Sound, Alaska on March 28, 1964. Use this information and the information at the top to find the intensity. So the intensity is y, right? That's what we're looking for, y. Okay, we are given the equation y equals 10 to the power of x minus 1. X is the Richter scale rating. That's the 9.2. So y is equal to 10 to the power of 9.2 minus 1. That's 10 to the power of 8.2. We're going to plug that into your calculator, and you're going to get 158,489. No, I'm sorry, it's 1,489,319.246. That's a lot. Okay. Write an equation of the form y equals log base 10 of x plus c for the inverse of the function. So the function is y equals, so here, so maybe we're confused, right? What is this talking about? Okay, what is this talking about? Write an equation of the form like this ridiculous thing for the inverse of the function. What function? Oh wait, I'm given a function right there, this one. Okay, so that's what I have. Oh, I need it to be like a log. Oh my God, I can totally do that, right? So what we're going to do is first, we want the inverse. What do we do for inverse? We switch x and y, right? Now, we want to write this in logarithmic form. So, here we go. Okay, what's the exponent? Y minus 1, right? What's the base? 10. So it's going to be log base 10 of x is equal to y minus 1. Now I need to solve for y. Add 1, add 1. So I get log base 10 of x plus 1 is equal to y. And there you have it. But I want an inverse. So it's going to be f inverse of x is equal to log base 10 of x plus 1. And that's it. Look, it's log base 10 of x plus some number. That's exactly what I got. So there you have it. That is the inverse. Okay, so that was 7.3. That took 14 minutes so far. Let's also do 7.4, right? Very, very similar. Okay, solving logarithmic equations. So we are figuring out right now that exponentials and logarithms are inverses of each other. And just like if I have 3 times x is equal to 9, to solve it, I need to divide by 3. And that division is the inverse of that original multiplication. That's how we solve any equation, by its inverse. So here we go. I have this equation. Log base 8 of x is equal to 4 over 3. Okay, so you have a logarithm. You're going to solve it by the inverse exponentials. So let's write it as an exponential form. This is the exponent because that's the answer to the logarithm. Every exponent needs a base. The base is 8. 8 to the power of 4 over 3 is equal to x. Oh my God, look at that. We already solved it. But now, let's actually simplify that like we did in the last chapter. You know what? Don't you miss roots? Let's write this as a root. Cube root of 8 to the power of 4, right? That's equal to x. Cube root of 8 is still 2 to the power of 4, 16. So there you have it. Okay, let's take a look at this one. Exponent is 3 over 2. So x is equal to the base to the power of 3 over 2. So x is root 16 cubed. That's 4 cubed, 64. Yay, let's do another one. Base to the power of the exponent is equal to 32. Do you see how I did the exact same thing? Base exponent equal to, power, right? I did the exact same thing, but now my equation turned out different. Well, how do I solve this for x? Okay, I raise this to the power of 2 over 5. I raise this to the power of 2 over 5. So x is 5th root of 32 squared. That's 2 squared. Yeah. Okay. Here we go. 1/2 is equal to 8 to the power of x, right? Base, exponent equal to the power. Ooh, what am I going to do over here? Now this is a completely different one. Now my variable is in the exponent. Wait, what if I do what I was doing before, right? How would I solve this? Well, maybe I can make the bases the same. So why don't we write the 1/2 as 2 to the minus 1. 2 cubed to the power of x. So now minus 1 is equal to 3x. So x is negative 1 over 3. Okay, what if you have logarithmic functions? So here's the deal. If you have identical logarithms, you can set the insides, the arguments, equal to each other. Okay, easy enough, right? Okay, so let's take a look at this one. Log base 4, log base 4, fantastic. We can set these equal to each other. So I get x squared equal to negative 6x minus 8. Okay, one thing. Yes, the logarithms are no longer in this equation, but we use this property to set their insides equal to each other. Please, let's refrain from words like, we cancel the logarithms. You don't do that. You don't cancel logarithms, right? Okay, so let's move everything to the same side. Let's factor. Oh, yay. So x equals negative 4, x equals negative 2. Now, you don't have to check your answers if you have an exponential equation, but if you have a logarithmic equation like this, if you have logarithms, more than one logarithm in an equation, you have got to check your answer. So why don't we go ahead and do that? Okay, so x equals negative 4. Let's check. Let's plug it into the function. Log base 4 of negative 4 squared. Is this equal to log base 4, negative 6 times negative 4 minus 8? So here I have log base 4 of 16, log base 4 of, 16. Okay, yes, that does work. Okay, now you have to do the same thing with the negative 2. Does that work? Why don't you take a minute to check x equals negative 2. Okay, it actually does work. So both of these are answers. Okay, what will not work? Sometimes you get different answers, but also if you get log base anything of a negative number, automatically that's a deal breaker. It's no. Okay? All right, so let's take a look here. Okay, log base 5, log base 5. I can set the insides equal to each other. X squared minus 10, 3x. So x squared minus 3x minus 10 is equal to 0. X minus 5, x plus 2. So x equals 5, x equals negative 2. Okay, so let's go ahead and check x equals 5. Log base 5. Okay, 5 squared is 25 minus 10, 15. Is this equal to log base 5? 3 times 5, 15. Yes. Okay, what about negative 2? Log base 5. Okay, what do I get here? 4 minus 10, that's negative 6. You can't have log of a negative number. Done. So you throw this away. Your only answer is this one. Okay, so this one we need to solve for m. Fine. Why don't we do that? So first, let's add 15 to both sides. Okay, now let's divide both sides by 7. So n plus 15 over 7 is equal to log base 4 m. Okay, where is that m? It's inside the log, right? It's a power. Well, I have log blah blah equals to something. This is the answer to a logarithm. What's the answer to a logarithm always? An exponent. Every exponent needs a base. What's the base? 4. So 4 to the power of this is equal to m, and there you have it. Okay, so here we go. That is section 7.3 and 7.4, and now you can do your homework. Have a good day, everyone.
Press start.